In activity 1.2, we'll be looking at scaling out Earth's layers. This will be found in your activity book. Materials that we will need for this will be some masking tape, some brass brads, a pencil, a pair of scissors, a meter stick, a piece of string that we cut to length of 1.5 meters, and also a piece of butcher paper that'll be cut to 1.5 meters as well. So to begin this activity, we need a starting point, which is for us is going to be in the center of the earth. So to mark the center of the earth and not tear paper, we're going to place a small piece of masking tape, which I'll have Lauren put on here, in the center of the paper at the bottom, and just fold it all the way across both sides of the paper. From there, we're going to place a brass brad in the center of that. We're just going to punch that right through the tape and spread that out, and this will mark the center of the earth here. And we're going to go ahead and tie the string around the brass brad. So you tie that on there for me. And our string here is going to be used as a compass to be able to arc the layers of the earth for each of these. So we have a nice curved arc for each of the layers that they're going to be defining on the paper here as we're scaling these out. The scales that we're going to be using are coming from our workbook that they've already calculated prior to getting this activity started. So from here at the Earth's center, we're going to be scaling out the 6,371 kilometers of the Earth to fit in this 150 centimeters worth of paper. In your booklet, we have the conversion factor that we're going to be using to calculate out each of our Earth's layers to be able to place within those 150 centimeters. So Lauren's going to go ahead and measure the first one, which she calculated out to be about 30 centimeters. And she's going to place a mark in the center of the paper. And then for each layer after that, she is going to stack those on top of one another. So she's going to slide her ruler up for the next mark, which measured out to be 32 centimeters. Now for each of these marks, we'll continue those all the way up until we get to the Earth's surface and the Earth's atmosphere. And then to do the arcs for each of these layers, we're going to have Isaac come in, and it takes 2 students to do this. Someone has got to hold down the center of the earth to keep the paper from moving. And then we're going to let Isaac slide in to arc out his layers. Now using the string like a compass, he's just going to pull that string taut, keep it tight as he moves the string back and forth to create nice smooth arcs to represent the Earth's curved features on the inside of the Earth's interior. And to go to each one of those, he just slides the pencil up. And we would continue all the way up the paper for each of those individual layers to create a nice pie piece or a wedge of the interior of the Earth, represented to scale the thickness of each one of those layers as we work from the inner core all the way up to the surface. After the students have completed arcing out their layers, they're going to be able to then go back and color code this based on the colors that are provided to you by your instructor. And also, they're going to be able to go through and research all the different layers and what those layers are comprised of with their different components, their thicknesses, their densities. All of those things can then be placed on this. This activity takes usually about a 40-minute period. So at the completion of this, the students should be able to go through and identify each of the layers based on their composition. So if we ask Isaac to go through these, starting it down here at the bottom where the brass brad was, he'd be able to run us through the layers.
This is the inner core, all the way at the bottom, and then the larger outer core. And then we have the lower mantle, followed by the asthenosphere, the upper mantle, and the crust, and then the atmosphere.
Where each of these are separated out due to differences in what?
Density.
And differences in density. And we can also look at heat transfer within this as we're moving from materials that are solid, liquid, solid, a semi-solid, back here to our lithosphere up here at the top, which is going to be a solid. We're going to be transferring that heat from the inner core on its way out from conduction, convection, conduction, convection, back to conduction and radiation when we get up into the atmosphere. So, Lauren, how do we know all of these different layers and their components if the deepest we've ever made it is relatively small? So we've only made it about that far into the Earth's crust.
We look at the seismic waves.
And what data do we get from the seismic waves that tell what are those seismic waves that they do as they encounter each of these boundaries?
They reflect and refract.
And the reflection and refraction of those waves is caused by what of each of these layers?
Changes in density.
It's the changes in density, good. So those changes in density within the Earth's layers reflect and refract the seismic waves that are produced from what?
Things like earthquakes and plate shifting.
Good, earthquakes. So it's geophysicists that are able to go through and monitor all these different seismic waves, which gives us this internal image, almost like an MRI of the Earth's interior. And it's through the use of seismic waves through thumper trucks at the Earth's surface that we're able to generate seismic waves that are then recorded by geophones by geoscientists for the oil and gas industry that allow us to develop an internal image of the Earth's crust of where we're looking for those hydrocarbons within specific zones in the Earth's layers. There are a lot of different careers within the oil and gas industry that use these type of techniques to identify different areas of hydrocarbons, such as geoscientists, geotechnicians, reservoir engineers, and geophysicists.